Hey everybody, welcome back. I wanted to get back into lesson 2 for crypto zombies and go over chapters 4, 5, 6, 7, and possibly 8, depending on how long this goes. So let's begin. Zombies attack their victims. Pick up where we left off. Okay, chapter 4, require. In lesson 1, we made it so our users can increase new zombies by calling create random zombie and entering a name. However, if users could keep calling this function to create unlimited zombies in their army, the game wouldn't be very much fun. Let's make it so each player can only call this function once. That way, new players will call it when they first start the game in order to create the initial zombie in the army. How can we make it so this function can only be called once per player? For that, we use require. Require makes it so that function will throw an error and stop executing if some condition is not true. So this is an attempt to kind of create scarcity and an exception block. If you're familiar with other programming languages, that's what this requires, kind of like exceptions. And once more, they introduce kind of cool blockchain lore into the lesson. Say hi to Vitalik. And this is the require statement here. If you call this function with say hi to Vitalik, it will return hi. If you call it with any other input, it will throw an error and not execute. So this is kind of like an if statement also. If this is true, keep going. If not, there's an error. Thus, require is quite useful for verifying certain conditions that must be true, i.e. like an if statement, before running a function. Put it to the test. In our zombie game, we don't want the user to be able to create an unlimited zombies in their army by repeatedly calling create random zombie. It would make the game not very fun. Let's use require to make sure this function only gets executed one time per user when they create their first zombie. Okay, so put a require statement at the beginning of a create random zombie. So create random zombie is our function here. The function should check to make sure owner zombie count message.sender is equal to 0 and throw an error otherwise. So again, I usually like to copy whatever they place, start it here, and we are going to take that back a notch, put it to the test, put a require statement at the beginning of create random zombie. The function should check to make sure owner zombie count message.sender is equal to 0 and throw an error otherwise. So we're going to do require owner zombie count message.sender close bracket is equal to 0. Close that off. Check answer. It's wrong. Let's see. Oh, I forgot to take out my copied text. Try it again. Victory. All right, next lesson. Inheritance. Again, this is kind of similar to most other programming languages. If you're familiar at all with object-oriented programming, that is what this chapter is about. It's a pretty quick chapter, and let's get into it. Our game code is getting quite long. Rather than making one extremely long contract, sometimes it makes sense to split your code logic across multiple contracts to organize a code. One feature of Solidity that makes this more manageable is contract inheritance, and then they give us a contract Doge, kind of like the Doge coin. So wow, crypto Doge. And then they give us this contract. Baby Doge is Doge. So this is their form of inheritance with Solidity. Baby Doge inherits from Doge. That means if you compile and deploy Baby Doge, it will have access to both catchphrase and another catchphrase and any other public functions we may define on Doge. This may be useful for logical inheritance, such as with a subclass, a cat is an animal, but it can also be used simply for organizing your code by grouping similar logic together into different contracts. So put it to the test. In the next chapters, we're going to be implementing the functionality for our zombies to feed and multiply. Let's put this logic into its own contract that inherits all the methods from Zombie Factory. So first, we're going to be making a contract called Zombie Feeding below Zombie Factory. Starting here, this contract should inherit from our Zombie Factory contract. So let's do contract Zombie Feeding is Zombie Factory. Open contract, close contract, and let's see if that's correct. And victory.